Hello everyone, I hope you all are doing well. In today's video I am going to describe little bit more about the atomic orbitals. Let's delve into the topic. Firstly, why we are getting so much knowledge about the atomic orbital is that we want to design the electronic configuration of electrons in an element, because we know that atom is the basic structure and we want to elaborate that structure more and more so that we get in-depth knowledge about the element. So that's why we are studying this atom. Now let's recall again what is shell. Shell is the outside part of an atom around the nucleus. Look at here in the diagram, you could see that a pink circle which have positive sign mentioned over there, that is considered as a nucleus. Outside, after nucleus, there are certain levels, that are certain circular rings, concentric rings have been drawn. These are called the shells, right? Very next shell or very first concentric ring after nucleus will be call it as K shell, or n is equals to 1. It is designated with the principal quantum number n. N is 1, 2, 3 and 4, and alphabetically we can call it as n is equals to 1 means K shell, n is equals to 2 means L shell, n is equals to 3 means M shell, n is equals to 4 means N shell, and so on. Now what is subshell? One or more orbitals in an electronic shell of an atom with same energy level is called shell. And look at here. In the diagram I have chosen that n is equals to 1 means always one thing kept in your mind, that when whatever be the principal quantum number, that number of subshells are arranged in it. Like as if n is equals to 1, that means it has only one subshell. If n is equals to 2, it has two subshell, that is 2s or 2p. We discuss it in little bit later on. N is equals to 3 means 3 subshell. N is equals to 4 means 4 subshell. Right? And in yesterday's video we have described about the atomic orbitals. S, P, D, F, G and so on. Now look at here how they can name the any subshell. N is equals to 1 from the principal quantum number 1, and the basic, as it has only one subshell, so the starting we get always start the subshell from S, right? So this is 1s. Now move to next level, n is equals to 2. That means there is a possibility of 2 subshell. The basic we have been chosen S. After that P. After that D. After that F. So there is possibility of only 2 subshells. So that is 2s and 2p. Similarly, moving to next side, n is equals to 3. We have studied that it has three subshell possibility: basic 3s, then 3p, then 3d, right? After this, n is equals to 4, 4s, 4p, 4d and 4f. And this diagram is quite helpful in order to understand the atomic orbitals arrangement as well. As I explained you earlier that 1s has only one orbital. That means it has a tendency to accommodate only 2 electrons. That means only one circle is shown, right? 2s means to s orbital is correspond to one circle, and there we can fill the 2 electrons. And 2p, we have studied that px, py, pz. Further, p has subdivided into three orbitals, so we draw it as 3 circles over there, right? 3s, 3p in the similar manner. D could be able to accommodate 10 electrons within it, so we can show it as 5 circles. right? In the same manner, 4f should be shown as 7 circles, so that each circle will be able to fill, each box or a circle will be able to fill 2 electrons within it. I think it would be helpful to understand the basic function of shell, subshell and atomic orbital. Now let's conclude it as we have studied today. Shell number is denoted by n. Then number of subshell are equals to n. If n is equals to 1, then only one subshell. If n is equals to 2, then 2 subshell. If n is equals to 3, then 3 subshell. If n is equals to 4, then 4 subshell. Then how we designate them? If one shell is exist, then we use principal quantum number, that is 1, and the basic atomic orbital s. We call this subshell designation as 1s. Similarly, it has 2, n is equals to 2 have 2 subshell, 2s and 2p. Similarly, n is equals to 3 means 3 subshell are possible. The further atomic orbital are 3s, 3p and 3d. In the similar way, 4 is included, 4s, 4p, 4d and 4f. Number of orbitals in subshell, that means he is talking about the circles. As I explained you in the subshell diagram, that if s orbital, only one subshell, that means one circle will be drawn, or one orbital. Better term is to use orbital rather than a circle to fill the electrons. We use orbital to fill the electron. 2s has one orbital, 2p has three orbitals, that is px, py, pz. Similarly, 3s again one orbital, 3p again 3 orbitals, 3d means 5 orbitals, d means 5 orbitals, dxy, dyz, dzx, dx square minus y square, dz square. Similarly, S, P, D and F. I think this would be helpful to, this table will be helpful to jot down all the things we have learned today. So that's why I choose this table. In the similar way, as I told you that one orbital equals to 2 electrons. So in the similar manner, maximum number of electrons in each subshell would be like that. One orbital means 2 electrons. 3 orbital means 6 electrons. 3 orbital means 6 electrons. 5 orbital means 10 electrons. In the 7 orbital means 14 electrons. It has a tendency to accommodate 14 electrons within it. To make this video, I have choose this book as a reference for today. Later on, we discuss another part or electronic configuration, how these atomic orbitals could be arranged in energy levels. We will discuss in our next video. Thank you so much.